Hello all. Today our topic is finite element analysis or finite element method. In short form it is known as FEA or FEM. It's an engineering analysis method. Why do we do an engineering analysis? We do an engineering analysis to check whether an engineering component will work properly in the actual working conditions. For example, if we design a cycle before going to the mass production, we will check whether that cycle will be working properly in the real working conditions. For that, we will load the cycle in the real working conditions and check whether it can withstand the load, whether it can withstand the stresses acting on it, or whether it can withstand the strain acting on it, all those things. All those analyses are known as engineering analysis. Finite element analysis is an engineering analysis method. As an introduction, let us see what are the requirements for an analyst when he design a product. Displacement at certain points, stress distribution, critical buckling loads, pressure, velocity and temperature distribution, crack growth, residual strength and fatigue like vibrations, etc. These are the variables to be checked when a design is completed. After design is completed, before going the product to the for the mass production. So in an engineering analysis, these type of variables, not in a particular product, all these variables may not be checked, but some of the variables will be checked to check whether it will work in the real working conditions. Commonly, there are three methods to solve engineering problems: analytical method, experimental method, and numerical method. Analytical method is the classical method. When we solve a problem using formulas like F is equal to ma, v is equal to root 2 gh, then that kind of approach is known as analytical method. We have solved a lot of problems in mechanics and mechanics of solids using analytical method. In textbooks and all, the method described is known as analytical method. It's a 100% accurate result. But one thing we should notice that only simple problems like cantilevers, simply supported beams, cylinders, etc. only can be solved using this method. That is the drawback of this method. Then the second method is experimental method. When we test a specimen to find out the stresses and strains acting on it to calculate the Young's modulus, then that is an experimental method. We do a lot of experimental methods in our labs. It is also an accurate method, but what is the drawback of it? It's a time consuming method and also it is expensive. Once a specimen is broken, it is useless. So to check a particular product in an engineering analysis, if we use experimental method, it is a costly method and also time consuming. Some of the experimental setups used are strain gauge, vibration measurement, sensors for temperature and pressure measurement, fatigue test. All these we can see in a laboratory. Then the third method is numerical method. It's a mathematical approach. Compared to analytical and experimental method, it is an approximate method. That means what solution we get from this method is not exact. It is only an approximate. But it can be applied to any kind of problems from simple to complicated. And results are more or less believable because we get approximate results and that is more or less will be accurate also compared to experimental and analytical methods. It is less time consuming and less costly method. So nowadays this is the most popular method used for solving engineering problems. Some of the numerical methods commonly used are finite element method, boundary element method, finite volume method, finite difference method, etc. Some more methods are there which are not mentioned here. Out of these, finite element method or FEM or FEA, finite element analysis, is the most popular method used nowadays. We will be studying in detail about finite element method in this topic. The different numerical methods are listed here: finite element method, boundary element method, finite volume method, finite difference method. The question is it possible to use all the above listed methods to solve same problem? For example, cantilever problem. The answer is yes. But the difference in accuracy achieved, programming ease, and time required to obtain the solution is different. Are FE and FEM different? As I said earlier, both are same. That's the term FEA is more popular in industries while FEM is at education centers. Now we can see what is finite element method, what exactly it is. In this method, body or a structure in which analysis is to be carried out is subdivided into smaller elements of finite dimensions called finite elements. Then the body is considered as an assemblage of these elements connected at a finite number of joints called nodes or nodal points. The property of each type of element is obtained and assembled together and solved as a whole to get solution. This is the method of FEM. So what is FEM? In this method, a large body, it can be of any shape. It is subdivided into smaller elements called finite elements. And then that body can be considered as the assemblage of these finite elements. And all these finite elements are joined at a point called nodes. Then each element is assembled together. The property of each element is first calculated. Then all these small elements assembled together, and at the end the body's complete solution is obtained. This is the method of FEM. Let us see what is meant by nodes and elements. Look at the figure. In this figure, it's a semicircle. It's not a semicircle, it's a quadrant of a circle that is divided into small parts. Those small parts are known as elements. It is of different shapes, rectangle as well as unsymmetric shapes. And at the corner as well as at the side centers of the nodes, there are some red spots which are numbered 1, 2, 3, like that. Those are known as nodes. So finite element analysis simply means dividing a large structure like this into small elements, and each element is connected to other elements through this kind of nodes as shown in figure. In this figure we can see the finite element discretization of spur gear teeth. It is the teeth of a spur gear. We know the shape of the spur gear, and it is divided into different types of small elements which are of triangular shape, and on each triangle we can see the black spots. Those are known as dots, and the triangular shaped small elements are known as finite elements. So this kind of discretization, the process of dividing a large element into small element is known as discretization. So this kind of discretization is the major part of the finite element analysis, and each part, in this case the triangular element, is considered separately as a small element, and calculations are done on each element, and at the end all the elements are combined together, and the result we will get will be the total solution of the whole element. This figure shows the spur gear teeth after the finite element analysis. Here the total deformation details are shown. We can see the spur gear teeth with a different color with different colors. Each color represents the total deformation magnitude. On that graph we can see red means maximum deformation, blue means least deformation. So blue color on the spur gear shows that that is in the safe limit, that is within the safe limit, and red and yellow are near the maximum deformation. So on that spur gear we can see where the red is developed, where the yellow is developed on a particular teeth on the top. That teeth is in the unsafe level. So we have to design that tip differently, and we should then only we can produce this gear in actual scenario. So finite element analysis gives these kind of details like total deformation, total stress acting, strain differences, all those things. This figure shows the transmission error in spur gear. The gray colored part shows the meshing. Meshing means division of the total figure into small parts, that is small elements, and the lower part in blue color is showing the part after the analysis, and that blue colored part shows the equivalent stress. We can show from that graph it is showing the equivalent stress acting on the transmission gear. So the red and yellow development shows that the equivalent stress is maximum in those areas. So from this analysis we can find that in which all areas the maximum stress is developed, that areas may be in the unsafe level, and we should redesign redesign the thickness of the teeth or some other dimensions accordingly so that it is within the safe limits. And why finite element method? Why do we use finite element method? Because FEA is the most widely applied computer simulation method in engineering. It is very closely integrated with CAD/CAM applications. It is a well proven, tested, and validated method for simulating any complex practical scenario in the area of structural, thermal, vibration, etc. We can see the FEA of an aeroplane and also a valve. So in all these areas, finite element analysis can be used. It is a very popular method. And next is the application of FEM in engineering. As we can see, the application is everywhere: mechanical, aerospace, civil engineering, automobile engineering, structural analysis. Structural analysis includes static, dynamic, linear or non-linear analysis. Then thermal analysis, steady state or transient analysis, electromagnetic, geomechanic, biomechanics, etc. So in all these areas, finite element analysis applications are there. Next, practical applications of FEA. Aerospace domain. We can see the finite element analysis of an aeroplane shown here. Then on the right side, that is the propeller of the aeroplane. Then in automobile sector, the automobile body designed in finite element is shown there. Finite element analysis of the wheel is shown on the right side. Then in electronic field, mobile mobile handsets, the stresses and strains acting on the mobile handset while we are holding it, or if it falls on the ground, that can also be simulated using finite element analysis, that is shown here. Then medical devices, it's a guitar, and many more applications are there for finite element analysis. And what are the advantages? Advantages: cost is less. Why cost is less? Because compared to other type of analysis like experimental or analytic, cost is less. Then design cycle time, that is less. Number of prototypes used is less. Here no need to use any prototype. Here we are using the simulation in a computer. We need not produce more number of prototypes like in the conventional method. Then testing is reduced. Then another positive thing is design optimization is improved. Commercially, there are a lot of software packages which are using finite element tools. If you want to do a finite element analysis, we can use different commercial packages as shown there. First one is ANSYS. As we all know, it is one of the most popular softwares used for FEA. Then SDRC, Nastran, Abacus. Abacus is also used abundantly. Cosmos, Algor, Patran, Hypermesh, Dyna 3D. All these are some of the software packages used nowadays commercially. This can be used for commercial purpose as well as for educational purposes. In most of the educational institutions, we can see ANSYS and Abacus. Then analysis types. Structural analysis can be two types, static and dynamic. Static analysis means analysis on a body which are in the stationary state. That can be linear or non-linear. And dynamic analysis means analysis on a body which is moving, which has got some velocity. So all these kind of analysis, static as well as dynamic analysis, can be done in ANSYS. As mechanical engineers, we will be more interested in structural analysis. So in structural analysis, both static and dynamic analysis are possible using FEA softwares. This is the first part of the lecture, introduction to FEA. In the next topic, we will see the steps in FEA, so that we can study in the next lecture.